This video illustrates an experimental setup of photoelectric effect. In this setup, we have a light source, we have a battery. A battery is connected to two plates, and in the circuit we have an ammeter to measure the current. We can set the battery to 5 different voltages. For the light source we have 4 different colors: blue, green, yellow, and red. We can set the brightness of each color from low to medium to high. This plate is connected to the negative pole of the battery, and the other is connected to the positive pole of the battery. If we start with the blue color, as you can see, the blue photons, they have enough energy to emit an electron from the plate. We can increase the brightness from low right now to medium. As you can see that when more photons are hitting the plate, more electrons are being emitted. When we increase more the brightness, even more photons are hitting the plate and more electrons are being emitted. As we all know that the blue photons, they have more energy than green, then yellow, and then red. So what happens when we switch to green photons? Now, if you notice that when we switch to green photons, there are less electrons are being emitted. Of course, the same phenomenon will happen when we increase the brightness. But again, I repeat, there's less electrons are being emitted when we compare the blue photons with green photons. Let's discuss the case of yellow photons right now. And here you can clearly notice that much less electrons are being emitted because yellow has much less energy than blue and the green. And of course, this is all due to the difference in the wavelength. As we have discussed before, the energy is inversely proportional to the wavelength, and blue has the shortest wavelength, and yellow has the longest wavelength than green and blue, and therefore it has a lower energy. Increasing the brightness of the yellow color, we can emit more electrons from the plate. Finally, we will discuss the case of red photons, where red photons, they have the longest wavelength, and therefore they have the lowest energy, and the energy of the red photons is not enough to emit an electron from the plate. Therefore, we don't see any electrons being emitted. Now, what happens if we go back to the blue photons, and if we now increase the voltage of the battery? As I mentioned before, this plate is connected to the negative pole of the battery, and increasing the voltage of the battery will increase the negativity of this plate. So we will see what happens when we increase the negativity of this plate. Are the electrons, they still can reach this plate or not? We will also read the current, the flow of electrons through the circuit using the ammeter. When the battery is set to 75 millivolt, on the ammeter we can read a current which is higher than 200. When we make this plate more negative by increasing the power of the battery, we can see that the current, there is less current passing through the plate. Even increasing more to 350 millivolt, the current is 100 nanoampere. And when we increase it to 500, the current is 80 nanoampere. However, when we increase it to 750, now the plate is negatively charged, strongly negatively charged. It's repelling the electrons, and therefore the electrons, they cannot enter the circuit. Since more electrons are being generated with blue photons, so we need a higher current to repel these electrons. If we try the same experiment with green, now we will see that with 70 millivolt, we have a current of 140 nanoampere. With 150, we decrease the current to 80. With a power of 350 millivolt, now the electrons are being fully repelled and no electrons are entering the circuit. We can do the same with the yellow, and we will find that with less power we can repel the electrons because much less electrons are being emitted using yellow photons. Now if we go back to blue, and we will just go to 350, so the current is 100 nanoampere. We will check if the brightness of the light source has any effect on the current. Now the brightness is set to low. We will set it to medium, and you will set the voltage to 350, so we have it at 120. We will set the brightness to high and set again the battery to 350. We have it at 140. This is all because when the brightness of the light source increases, more electrons are being emitted and therefore more electrons are passing through the circuit.